to the program. Last one, number 23. Valeria wants to buy turquoise stones on her trip to Colombia and give at least to 5 of her friends. The gift shop sells these stones for either $4 or $6. Okay? So, and Valeria has no more than 30 to spend. So, the first equation is going to be x. Okay, it says let x equal the number of stones and y equal the number of $6 stones. So x is the $4 stones. So no matter, the sum of both kinds of stones must be, she says, at least 5. So we're going to say minimum 5. Right? So that's our first equation. The second equation, she don't have any more than 30 to spend. So the max is going to be 30. Right? So we know that each one costs $4 for the x, and the other one is going to be $6 for the y. So those are our two equations. And we're going to, this is a linear problem, and most of the problems before this were quadratics. This is a linear problem, and we're going to have to simplify these. So let's take this. This is equation 1. This is equation 2. We have here y must be greater than or equal to negative x plus 5, right? And then the second equation, we're going to say, so this is still equation 1. The second equation is going to be 6y must be less than or equal to negative 4x plus 30. We got to divide everything by 6 here. We have y must be less than or equal to negative 2/3 x plus 5. Okay, so we have to graph these. We have to graph this, and we have to graph this. So the first one, number 1, if I let x be 0, then I have y must be less than or equal to 5. So that would be, this is for the y value. So we have 1, 2, 3, 4, 5. We put a dot right there. But if I let instead y be 0, I have 0 must be less than or equal to negative x plus 5. So then I have x must be greater than or equal to 5, right? So that would be on the x-axis. 1, 2, 3, 4, 5. There's the dot. So I do a straight line there. Okay, that's my linear for that one. I got to do the same thing now for this equation, the second equation. If I say y must be less than or equal to, I make x 0, I'm going to have 5 here, right? So that would be 1, 2, 3, 4. What do I do here? That's going to be 5 also, right? But if I say let x be 0, if I let y be 0, then I have 0 must be less than or equal to negative 2/3 x plus 5. And then I'm going to subtract 5 from both sides. So now I have negative 5 is less than or equal to negative 2/3 x. Then I multiply everything by the reciprocal of 2/3. I will get here x must be less than or equal to negative 5 times negative 3/2, which is going to be, this is going to be positive 15 over 2. and that's x. So then x must be less than or equal to 7.5. So that would be, this is 1, 2, 3, 4, 5, 6, 7. So then that'll be there. And then I have another linear. So the solution lies here. And we want to do all of the points that are in between here. So there's a point there, 1, 2, 3 different points that we could use. What is the value? So we could say 3 $4 stones, and so I'm looking at 1, 2, 3. I'm looking at this one right now. 3 $4 stones and 2 $6 stones. So that's option 1. Option 2 could be 2 $4 stones. I'm looking at this one now. And 3 $6 stones. And then now the last one, we'll do this one right here, which is 1, 2, 3, 4, 5 $4 stones and 1 $6 stone. Thank you for watching.